is chapter number 4, unit 1 of data science in the MSc subject. Now, let's see that we have learned so many layers. So, one layer is our business layer. Let's understand the business layer in detail. And this is also chapter number 4 from the book. So, business layer is the transition point between the non-technical business requirement and desires. That means each business has its own requirements. So, from the non-technical requirement, it should be converted into practical data science requirements. The business layer is where we record the interactions with the business, and we convert business requirements into data science requirements. So we can have many examples, like if I want to know that which color of the car will be required in the market in next 3 months. So this is my business requirement, because based on that the car company can actually build more cars with the specific color. Like if suppose the white color, blue color or red color will be in demand. So if this type of information can be given to the business, then we have to first convert it into a practical data science requirement, where we have to understand the need of the business. We have to also understand that what is the requirement of business, and accordingly we have to give the data to that particular business. So now the functional requirement. Functional requirement, it records the detailed criteria that must be followed to realize the business aspirations from its real world environment when interacting with the data science ecosystem. It also means that we have to understand the real world environment and how this real world environment is interacting with the data science ecosystem. So our data science ecosystem will have the data vaults, it will have the data marts, it will have the data warehouse. So how this data can be extracted from this huge data marts is our functional requirement. These requirements are the business view of the system, which can also be described as the will of the business. Now, if we are able to find out the functional requirements, then we have to find out using this MOSCO method. MOSCO means must have. So requirements with the priority must have are critical to the current delivery cycle. It also means that we can divide our requirement into 4 sets. Some properties or some requirements are must. So the system must have that requirement or must fulfill that requirement. Some requirements should have, some could have, and some won't have. Okay, so let's go with the first requirement, that is the priority must be given to such requirement because these requirements are must in the delivery cycle. Then should have, requirement with priority should have are important but not necessary to the current delivery cycle. So the requirement can be included, if not possible in the current delivery cycle, it can be included in the next delivery cycle. Then could have requirement prioritized as are those requirements which are desirable but not necessary. That means it is we can provide that requirement, but without that also our delivery cycle is complete. So we may or may not provide that requirement, but there are some requirements which are identified by the stakeholders as least critical, or you can say the lowest payback request. So these requirements cannot be included in the current delivery cycle. So we can say that these requirements will not be there in the current system. So all our requirements should be categorized into 4 types: must have, should have, could have, and won't. And then accordingly we can provide it to the user. So must have requirement should definitely be provided. Should have can be provided in the next delivery cycle. Could have might be provided but not necessary, and won't will not be provided at all. Now let's go to the next method. So of course when we are able to categorize our data, then we have to think of the general functional requirements. Now, general functional requirements should be definitely there in our delivery cycle. Like if a user is not asking for a login page, sign up page, or a registration page, still the requirements should have those pages. Same way, all the general functional requirements should be provided to the user, whether the user has asked for it or not. Now, specific functional requirement, specific helps in creating requirement that enable us to transform a business aspiration into a technical descriptive requirement. So the data mapping matrix can be used. The data mapping matrix is one of the core functional requirement recording technique that is used in data science. It tracks every data item that is available in the data source. Then we can have the Sun model. So Sun model is widely used because it is more useful. The Sun model is a requirement mapping technique that assists in recording requirements at the level to allow the non-technical users to understand the intent of data analysis. So it's a very simple technique, and even the non-technical users can also understand the analysis. So it's easy to do a transition, or we can go for technical modeling. That is why all the data scientists and engineers, they prefer the Sun model. So let's see the Sun model in much more detail. So this is a typical example of a Sun model. Now here you can see the dimension of a person, dimensions of a location, and the dimensions of a date. So in every for every record, if suppose the information is leaves at, so the person's dimensions are the person's title, last name, first name, person key. And for location, the dimensions are location name, altitude, longitude, latitude, and the location key. The dimensions for date are day, month, year, and date key. So all these information can be stored for a particular person, and we call it as a Sun model. So this is a typical example of the information that is stored for a person to understand what the person's information is, and on which date the information has been recorded, and what is the location of the person. So we will see Sun model in more detail in the next